Hello everyone, I'm Xiaogan. We'll briefly go over the remaining documents for you. Because these documents are quite complex and also relatively advanced, very in-depth, I can't fully explain them all to you. So we'll just touch on them briefly. Then, if you want to learn about networking, you might need to look at this document because the entire network architecture is very complex. For now, we really just need you to know how to use it first. Only after you know how to use it should you delve deeper into these things. That is, when you study this, you still need to understand this document. You'll need to have nearly 3 years of experience before you can understand it. And this 3 years of experience, it's not like you're the one doing this digital male character or something. Because when you make a digital male character, it's all single player. You won't be writing this smiley player game, so at least you need to have a very deep expertise. To understand the goal of our set is not to do that. So then you can hear, we'll translate it into Chinese. We'll briefly explain to everyone. Each of its documents all are meant to explain to you what kind of thing to talk about and what kind of content. We can right-click to translate it into Chinese. I used Microsoft Bull Server here. Let's first look at a relatively complex document. It explains to you in detail the replication process of this actor. When it replicates, how exactly it replicates. And these replications work through functions to perform tasks. Right, and these are equivalent to the methods that exist within the actor. You can just compare them yourself. And this is how the replication process goes. Some work will be performed before the replication process. For example, determining the update frequency, and then whether it is currently replicating or dormant, etc. That is, you understand it conceptually. Just knowing that this exists is enough. If you want to set a brainmite, you will need this debug symbol, or having the Unreal Engine source code is best. Then when you receive a property, for example, look at this place. We have a demo here, right? Let's put it here. You can take a look at this. When it executes an RPC, this breakpoint, how it proceeds step by step, break it off from there. You turn from the stack once you push in step by step. But what I recommend is you just take a look at this. First look at the Jihu documentation. Then look at debug this source code after finishing debugging the source code. Then combine it with the official documentation to interpret. Then take a look at the historical article analysis just posted. Look at this on replay. Where exactly did it come from? And in this place, this part involves the network. It has a bunch package. Then inside the bunch package, UReliable RPC, not reliable RPC, and property synchronization. Then the order between them. How is it guaranteed? Actually, regarding this, there is a classic mistake. That is, after I spawn an object, I immediately call a method on that object from the server, and I expect my client to also call that method. This will cause they are sent within a single package. After sending, when you later call that method, it occurs before the generation method. Within this same frame, the client has not yet generated it, but you call its method. This will cause a crash. If you don't have protection, if you do have protection, it will result in failure. So in this case, there is actually a timing issue. It's a common mistake. For example, you generate an object and you immediately use it. But when the client receives this information, it hasn't generated this object yet. You can see some actor channels here. You can see this U channel. So these channels, how do the actor channel and this light driver interact with each other? How do they distribute information? This thing is much more complex. Then the server connection we talked about on Weibo, many times more complex. You can see the underlying source code. You can set a breakpoint and debug them one by one. For now, just get a general understanding. And this place is connection and channel, how they interact with each other, how to establish correlation, judgments on whether to sleep. We'll just briefly go over it. Next, there is also Lightwork dormancy. You can see these documents. Actually, they're from 5.3, only available in 5.4. If you flip further back, if you flip to the very beginning, it's not there. Actually, the official team hasn't had time to translate it yet. Everyone, take a look for now. After translation, it becomes network sleep, because here, you can set ATO to sleep mode, so that it will no longer see. You won't hear sudden footsteps. And when you need it, you can wake up this E2. So when it's sleep, there are several states. It suggests that under which circumstances you should use which type of sleep. But we won't put some things to sleep for now. You can adjust them gradually. Later when optimizing, learn how to set the sleep time for waking up. Sometimes when we update, we need to immediately replicate this to the client. Then you can call this ForceNetworkUpdate. This method is sometimes used when we need to make some immediate turns. That is because you don't for some extreme operations, like a 180-degree turn. If you don't force an update, then on the server, you have already forced the turn, but your client is still using your previous forward direction date, then the positive direction will form a pull, a tear. So sometimes you can consider some forced update method. Then during sleep, it must have a hanging amplitude. Some charts are used for judgment settings. Okay, as for this part, let's look further back. What are the documents are more complex? This document is also quite important. As for this document, it mainly means it has an RPC execution order because its attributes are often some are reliable, some are unreliable. When it is very reliable, it must have a stack transfer. They need to be sent one by one, received one by one. When it is unreliable, it will cause some later ones to arrive first, and the ones that arrive first, the ones sent first arrive later. This will cause a problem. Then we try to, if you want stability, then you can execute RPC reliably. But sometimes you just are not very stable. Then you can essentially not need to, write code yourself. Just keep it in mind. And here, the first method is cross-character sorting. This is still very important. Let's practice it. That is, you have many actors, and in one piece of code, you call this kind of RPC. Then it executes on the client side. That is, it is received on the other end. It is different because some actors may be fast, and some actors may be slow. You can't really explain this clearly because of its update frequency. This combination, then it's possible that these 1, 2, 3 are cross-character RPC like this. It definitely won't work. But if you are an actor, as for this, then this kind is stable. That is, you need to remember this. Because this way of writing is stable. That is, you are in one place, and then you call a stable RPC once, then it's okay. And then if it's you have some components here or some that are synchronized. Some objects have been synchronized. So if you adjust it this way, then in fact it will also be stable like this, but sometimes it becomes unstable. This instability comes from mixing approaches. That is, you have both stable parts and unstable parts. So at that point, you won't be very clear. You won't be clear about what the situation actually is. And here's the thing, because it is inherently unstable, it's very likely that due to some network issues, it might get dropped. So here we have a CAC ordering and an unreliable ordering. Just keep a general impression in mind. And this part is more complex. It's the ordering of single wave and multi-wave. Now, what this means is if you have reliable multi here or single wave RPC ordering like this, then this part is reliable. Anyway, remember that unreliable is absolutely unreliable. It could be fast or slow, and then this unreliable multi-wave and other single wave. Between reliable multi-wave is simply unreliable. Yeah, then the order of this RPC. I recommend you still take a look at that Jihu document. This part only solves the issue between our pieces. Actually, many times during interviews, they will ask you about property synchronization and RPC. The question of which arrives first. This thing is, you'll need to look at the Jihu document and debug and test it yourself. Anyway, my suggestion is, when developing on your own, don't force it. Let it achieve reliability amidst unreliability. If you want reliability, use the previously mentioned cases. Just use all reliable methods, then call them sequentially within the same character. These are the strategies. This part emphasizes the order between RPC and ACTOR properties. For example, here it calls a stable RPC, then enables a property synchronization, and then enables a multicast, which is equivalent to an unreliable broadcast. Then another property synchronization comes, and then a reliable one. Then, when the remote computer executes it, it might be like this. This is executed in order. You will find the stable RPC. It must be executed first, Then next is this property synchronization. Then after that is this unstable one. Then you will find that here, there's a rule will come up in the interview. The interviewer will ask you, if they are quite skilled, they will ask you if an unreliable multicast RPC and a reliable RPC, and then this property synchronization. How do they work together? Then the rule here is, it is executed after the application update is completed. So this place means, if during processing, when queued, it may not have this property update. They may not be in the same update. Then it might update in this order. And this might mean this relies on RPC1. It might be dropped, possibly dropped in this case. Then it might be in this order, and the network simulation here is that you can force set some packet loss rates or something to simulate what happens under such unreliable network conditions. What kind of situation will occur? That's roughly the idea. Then let's go through the other documents as well. This part means you need to, you need to replicate an actor component. You actually, in the constructor of the actor component, you need to enable the actor itself, and then enable the default settings of the actor component. If it's dynamic, remember, if it's a new object, meaning a dynamically created component, then after you create it here, you also need to manually enable it. That's quite simple. For blueprint, you can just check this box. Doubling is also relatively simple. Okay, so this can be considered as directly calling. It should be enabled through blueprint just by using the copy function. And here are some other things. Actually, they are mostly the same. This part is not much different. Then let's take a look at copying child objects. As for this child object, it is actually not a component. It just writes here the UObject class and then attaches this UObject class here after attaching it here. In this way, it is made to perform such a replication function. This is essentially equivalent to attaching a UObject on the heap to your actor. When you do this, there may be some potential issues. For example, after you finish creating it this way, you will also need to correspondingly perform a simple destruction of it. Right here, when you clean up, you still need to destroy and clean it up. That's roughly the idea. We generally use this actor component, which is better. This part contains some other code examples. Let's take a quick look. Just ignore this. Okay, so for this slightly more complex document, we'll stop here. Remember, it must have an owner. An owner means the owner must be on the server to perform a switch, because we know a character needs to be attached to that controller. And we may need this RPC and property synchronization. We'll guide you through these two things after you get pretty good at it. Actually, our basic part is pretty much done like this. As for this multiplayer observation, this is also something that during interviews is often asked. You might need to search and refer to online tutorials to implement this seamless switching. Our main focus is actually to understand this server trivial thing. Generally speaking, in Unreal Engine, there are two ways. One is seamless and non-seamless. As for seamless, it is actually a non-primary color operation. Rather than a seamless transition, it is a primary color operation. Then it is equivalent to executing this. When executing this non-seamless operation, it will disconnect. It needs to be reconnected. It is similar to this open live situation. So sometimes the most important thing for us is still to use the serial travel. This serial travel, it means the server will jump to a new scene and map. Then other players, they will automatically jump over. As for our kind-tide operation, you just need to climb tribe. Whichever server you want to go to, you can only get there by climbing tribe. Then this engine boards, it is equivalent to, it hard loads this map and then disconnects all client players. Yes, and roughly speaking, you just need to master and know these three methods. As for seamless transitions here, it's a bit more complex to implement because other seamless transitions, actually, it's right here. Let's turn this off. It's right here. There is one here. There is a map here. You need to specify it inside this translation map. In the editor, you might not be able to use this yet. You may need to package it first, or perform some operations before using it. If you enable it here, you need to specify the map, then it exists in the constructed map. This is because it needs. You cannot load a new map. You cannot release the original level, because in UE5 we always need a level to load. You cannot have both the old and new levels exist. That is, We first go from the old level to a transition level, then complete some data processing in the transition level, then go from the transition level to the new level, which is very convenient. So if you enable this option, you need to enable seamless travel in the game mode to achieve seamless level switching. As for the seamless switching process, first you need to check which actor do you want to retain, then transfer it to the past, then retain it in the final level. Just do a transfer, and here you can do some things like an inventory bar or an item bar and retain some things here. But I think this process is still quite complicated because you need to use this method to convert the old player state and the new player state or gamer, similar to related gamer play classes, to do a connection and conversion. Such a task, only then can it be done. Everyone now understands this part. It is enough to understand this part for now. And actually, when I develop it myself, I prefer when I directly clear and switch levels. I just give it a C whereas H. That is, it's like taking the items from its backpack, directly storing them in the game instance. Then, after we enter the new level, we let it respawn and regenerate again. This way, isolating it is better. Alright, that's about it for now.